Hello, ladies and gentlemen, and welcome back. We're midway through Part C of the 2006 Cayley contest. We're on question number 23, so hopefully you've given this one a try, and you're just coming here to compare your answers. Quincy and Celine have to move 16 small boxes and 10 large boxes. The chart indicates the time that each person takes to move each type of box. Okay, so over here, Celine takes 2 minutes to move a small box. Quincy takes 3 minutes to move a small box, and Celine is 6 minutes for a large box. Quincy's 5 minutes for a large box. Okay. They start moving the boxes at 9 a.m. The earliest time at which they can be finished moving all the boxes is... Okay, and then we have some interesting options. Maybe it takes them 45 minutes. Maybe they can get it down to 41 minutes. All right, so based on the chart here, I think it's clear that they don't move the boxes together. It's not Celine and Quincy are both moving a large box. Celine, large box, and kicking it down the hall, and she takes 6 minutes to do so. Maybe Quincy was in soccer. She's kicking the large box down the hall in 5 minutes. And, of course, small boxes they would carry. But the point is, it can't possibly take Quincy 3 minutes and Celine 2 minutes if they're both carrying the same box. They'd be done in 2 minutes or 3 minutes, something like that. So we're dividing the boxes up amongst Celine and Quincy. There's 16 small boxes to divide, 10 large boxes to divide. And we can, given the number of small boxes that Celine carries and the number of large boxes that she moves, we can figure out how long it would take Celine to perform that task. So what we're going to do, I suppose we could have started in the last half of that page, but I like to keep the C-part questions on separate pages. I'm going to say, let S be the number of boxes, of small boxes Celine moves, and L the number of large boxes. We use the curly L, or the script L, because we don't want to get confused with regular L. Which looks like a 1. Okay. So, if Celine's moving S small boxes, then that means Quincy moves 16 minus S, and 10 minus L. Okay. So we can get a formula for how long it takes Celine to complete her portion of the work and Quincy to move his boxes. Okay. So Celine takes 2 times the small boxes plus 6 times the large boxes, if I'm remembering the chart correct. So that's how long it takes Celine to complete her portion. And Quincy, he takes 3, 16 minus S, plus 5, 10 minus L to finish. Okay? Now, you might go into this thinking, hey, we'll just give Quincy all the large boxes and Celine all the small boxes because, that's how fast they go. But you'll find Celine is done in 32 minutes, and Quincy is done in 50 minutes. So, I mean, that's a big enough difference that you'd say maybe we give a large box to Celine. Maybe we give a couple large boxes to Celine. That brings down the time it takes Quincy to do it, starts moving Celine's time up. What we want is for these two expressions to be as close as possible. Okay? So, what I'm going to do is I'm going to sort of set them equal. First, I'm going to expand this out. Minus 3s and 50 minus 5l. I want these guys to be as close as possible in their expression. So I think it's best to try and set them equal to one another. Maybe. I don't know. See, the thing is, these equations should be roughly the same, and that is 2 equations and 2 unknowns, but then I don't know what this k is. And that becomes a bit of a problem for me because now I've got two equations and three unknowns. So maybe just a pure algebra setup isn't the right way to do this. So let's think of a different way to do it. Okay, we'll keep this if we need it, but let's think of another way to do it. I already said if S is 16 and L is 0, then Quincy is done in 50 minutes. Celine in 32. Okay? So that means overall it takes them 50 minutes. So we want to minimize Quincy's time. I think maybe we make a chart. So we'll have Celine's time and we'll have Quincy's time. These formulas are not lost on us, but so that would be 32 and 50, and then the time it takes them is just going to be the maximum of C and Q. So in this case, 50. Well, I can definitely bring the 50 down, because it doesn't take, I mean, at worst it seems to take them 45, is what they're thinking in the question. So what could I do to bring this down? Well, I could give Celine a small box. Actually, let's see what, we'll see what happens if I give Celine a small box. So it increases this to 38 and drops this down to 45. So now it takes them 45 minutes to do this. But you'll notice there's still a fairly big gap. So I'm going to give Celine a second large box. So that pops this up to 44. And now Quincy comes down to, he's moving less boxes. So he's now down to 40. And now it takes them 44 minutes. So I think we can play around with this chart, and I think it'll be a little more elegant than what we've got. What is trying to set those two equations equal to one another or something like that. So now Celine is the one who is overworking. So let's give her not one less large box, because that would put us back to where we were, but let's give her a less of a small box. So 15 and 2. So now she has 2 minutes less of work to do, so that brings that down to 42. And what have we got here? Quincy, it takes him 3 minutes to move this brand new small box he's been handed, so that's 43. So I think 43 will be the best that we can do. I don't see, so you might think it's 42, so I think that's why they have 42 here. And 41 is probably just for the people who guessed the lowest estimate. But I really think 43 is the best that we can do in terms of because they're only off by a minute. Now that said, maybe there's some other combination. So let's I don't know, let's remove some more small boxes and add a large box or something like that. So if it takes Celine 42 minutes. Well, if I remove 3 of her small boxes and add on 1 large box, now it still takes her 42. 24 plus 18, 42. And now Quincy takes so 98 minus 3s minus 5l. Takes 36 minus 15. So now it's taking Quincy 47 minutes. So I really think 43 is the best. I could guess at that, but what I'd like to do is see, is there a way to actually show 43 is probably the best that we can do? So 2s plus 6l is Celine's time. I don't know what that is. And 98 minus 3s minus 5l is Quincy's time. So if I add these two together, I get 98 minus s plus l equals the total of their individual times. Okay. Now, what can I do here? If I'd like to minimize the total of their individual times, which isn't necessarily the best thing for us to do, because I think if we minimize the total of their individual times, we'll get the 16-0 case here, which, yes, 82 total minutes, but still had the max 50 minutes. So, so the min total time is 98 minus the 16 plus the 0, the S equals 16, L equals 0 case. And that's 82. So if it were to take them 41 minutes, we'd have to have 41 and 41 be their time. Okay? But the only way to do this is the 16 here and 0 here. There's no other way to get 82 for their total time. Now, if they were to get... so this is the worst they can be. If the 41 was their max, it'd have to be 41 and 41. Now, if it was 42 was their max, they could have things like 40 and 42, or you could have 41 and 42, or 42 and 42, that sort of thing. You get 84, or 83, or 82. Well, there's no way I can get this to be 82. The only way that gets me 82 is the 32-50 situation. If I wanted 42 as their max, I would need that tab, so maybe 98 minus 15 plus 0, that's 83. But I think we can see that that's going to be even worse, because that's going to be 30. 30 plus 53, and that's no good. So that turns into 30 plus 53. Or I suppose I could have 18 minus 16 plus 1, and that also gives us a grand total of 83. But that's this that gave us 45 as the max. So that was 38 plus 45. So there's no way I can get a total of their times being 83 and have a minimum time of 42. How about the 84? Because that's the real one. If I want 84 expressed as 42 plus 42, what will I need to do? Well, I could do 15. I could do 14 plus 0. I could do 15 plus 1, or I could do 16 plus 2. Okay, this one here is going to be 28 and 50 something. So it'll be 50 plus, so it'll be 56. And this one here is 30 plus a large box. So that's 36. And 48, which I think is one we already dealt with. No, we didn't quite go that far, but we're still not where we want to be. And then 16 and 2 gave us 32 plus a 6, so that's 38. And so it has to add up to 84, so 46. Okay, so those are the best that we could do. And it still wasn't quite enough. Actually, is it 38 and 46? 32 plus another 12. No, I think it's 44 and 40. Don't know what I was thinking. But my point is, we have shown that there's no way to do the 42-42 or 41-42 or 40-42 that would give us a max time of 42, because the total of their times has to be something like this. So 43 really is the max. Okay? Now that was a lot of work just to show 43 is the max. We did it. We're exact. We know it takes them 43 minutes at best. But, you know, unless you started out by adding their 2 times and going through it this way, I think the work you did ahead of time and saying, gee, I really can't think of one, that would be enough to justify a guess at 43. Remember, this isn't a written contest. This isn't the Euclid. So you don't have to rigorously prove everything. If you know the answer, you bubble it in. Okay? And if in fact you were wrong, but you just couldn't see that one little exceptional case, okay, you screwed up. You have to be okay with that. It's a contest. It's not a math exam. Okay? So not getting full marks on the Cayley of all things, not that big of a deal. Yeah, I could understand you'd be upset if it was the Fermat or the Euclid. Those are some more important contests. But the Cayley, you don't get Part C. Big deal, And it might be a big deal to some of you, but really, it shouldn't be. These are supposed to be for fun. They're supposed to be interesting little challenge problems. And, I've guessed in my day when I was sure the answer was something, and then, no, I thought about it later. I was wrong. I missed an exceptional case, or I forgot whatever theorem applies. But, yeah. Don't sweat the small stuff, and don't waste time rigorously proving something if you're pretty sure you've got the answer anyway. No, we got to remember, we got 2 more questions to go through, so got to devote time to that as well. So, thank you guys for watching, and I will see you for question 24 in the next video. Have a good day.